Hello, let's continue this series of videos. Today we will solve this challenging integral. At the end of this video, there will be a bonus part, and I will show you an amazing byproduct from this integral. So keep watching it to the end. Before we move on, don't forget to subscribe my channel, turn on the notification, and give a like. Let's get started. So first, let's look at the output from the Wolfram Alpha. Here we require A is positive real number, and K is non-negative real number. So you can see Wolfram can't solve it. It says the standard computation time exceeded. And then I set a number to A. Here you can see I set A equals to 2, but Wolfram still can't solve it. And finally I set a number to K. Here I set K equals to square root 3, but Wolfram still can't solve it analytically. Instead, it can only give the approximated numerical result. So Wolfram can't solve it, but we can solve it by hand. Actually, I will use a very simple method to solve this problem. The first step is a key step. Here we use a reciprocal substitution. We let x equals to 1 over u, and then we do the derivative so we can find dx. After plugging the substitution to replace x and dx, we got here. And note for the lower and upper limit for this integral, because we use a reciprocal substitution, so the limits are flipped. And then we write the denominator into this form. And next, we use this negative sign to flip the lower and upper limit back. After flip the integral limit, we got here. And then we can simplify these two terms by distributing the u square into the parentheses. And next, we multiply u to the power k to both numerator and denominator. So for these two terms, we can distribute the u to the power k into the parentheses to simplify it. And then we write the denominator into this form. I copy it here. And record the original problem here. If we compare the blue term to the blue term, or compare the green term to the green term, we can find they are very different. But the idea is we want to convert it into the original format. Here I take this blue term for example, and I want to convert this blue term into a squared plus x squared. So what should we do? Maybe you want to make a substitution to let a times u equals to x. In this case, this blue term goes to 1 plus x squared. But what we want is a squared plus x squared. So this substitution doesn't work, but it's very close. So here we make a substitution to let a times u equals to x over a. And equivalently, we can solve for u, which is equal to x over a squared. And then we do the derivative to find du. And next, we plug in the substitution to replace u. And then we plug in to replace the du term. And next, we expand the power for the numerator and the denominator. And next, we write this integral into this form. The first term goes to here after cancel out the a squared. And the second term goes to here after cancel out a to the power k. I copy it here. And then we can simplify these two terms by distributing a squared into the parentheses. And next, we multiply a to the power k to the numerator and the denominator. And then we can simplify this term inside this green box by distributing the a to the power k into the parentheses. And next, we simplify the numerator and cancel out the a to the power k. And then we put the a to the power k into the denominator. I copy it here. And next, we multiply a to the power k on both sides. So these two terms cancel out. And we got here. And record the original problem. Similarly, we multiply a to the power k on both sides. And then we add these two equations together. So we got here. And for the right hand side, we can group them into a single integral. Because they have the same denominator, so we can write it into this way. And these two terms cancel out. So we got here. And then we divide this green term on both sides, so we got here. I copy it here. And next, we make another substitution. We let x equals to a times u. After plugging the substitution, we got here. And then we factor out this a squared term. After cancel the factor a, we got here. This integral is simple, so we just integrated and got arctangent u. After plugging numbers, we got here. So we got this final answer. If you still remember, in the very beginning of this video, I said there's a bonus part. So let's go back to this integral again. Here is the result for this integral. And let's see what happens if we set a equals to 1. For the left hand side, 1 squared equals to 1, and 1 to the power k is also equal to 1. So the left hand side goes to here. For the right hand side, if we plug in a equals to 1, then it goes to pi over 4. So can you see this amazing result here? This integral is independent of k. So no matter what value you choose for k, this integral is always equals to pi over 4. So this integral is invariant. That's why I said this byproduct is amazing. And don't forget to subscribe my channel and give a like. That's all for today, and thank you for watching.